Okay, so we're recording now. Can you hear me? Yeah. Yes, perfect. All right, good. We figured it out. Figured it out. It's good. We can now share screen. Now we should have done. We go to continue. Now we just share screen. And ta-da, this works. Okay, good. Very good. Figured it out. All right. 6:04. Okay, qualifies. Welcome back. Good to see you again. So the class is decimated. I know this. Okay. What is it? Is it R or is it me? I hope it's not me. Okay, but welcome back from the break. Great to be back. And now we finally have some form of ventilation. Is it too loud? Okay. Okay, we will be talking today about central tendency and variability. As you can imagine, this is based on what we have learned on the depiction of data, quite an important topic. So we talked about histograms, we talked about dot plots, if you remember, and all of this essentially shapes the distribution of our data. So essentially, we want to understand how data shapes, how data looks like, and we also want to have means to numerically describe our data. This is why central tendency and variability is super important, because that's the means to essentially describe your data numerically. Good, but first things first, we have a quiz on Wednesday. So I hope all of you have done the practice quizzes that you have in the chapters. So all the chapters can be practiced. I intentionally put all those practice quizzes in there because the questions on the quiz will be from those 4 practice quizzes, including what we're going to discuss today. So I'm giving you the opportunity to practice what you will be quizzed on Wednesday, to practice those without any ramifications. You do those practice quizzes, you run all the practice quizzes. It's total around 800 questions. You do them as often as you want, you memorize them, you're good to go. You're gonna ace the quiz on Wednesday. The idea behind it is that these quizzes will cumulatively prepare you for the midterms as well as for the finals. To answer the question on these quizzes, you need to understand the concept, you need to understand the material, and you need to have studied. The quiz questions are kind of tricky, but you will be able, if you watch the recordings, if you do the exercises and you follow along with material, you will be able to answer them. And then it's just a question for you to kind of practice the questions, understand how the questions are asked and how you can answer them on the quiz. Okay? Yes? Is there any elements of Excel in the quiz? No. Well, there will be elements of calculations. So Excel will be important. So you will need to calculate, particularly later on, you will need to calculate t-scores, now means and standard deviations, but you will need, Excel will actually make it easier for you. So yes and no. So it will not really require you to fill out a spreadsheet and do a spreadsheet and submit the spreadsheet, but it will require you to know how to calculate things. And that is easy with Excel. Yeah. Yes.
It's all on Canvas for the video quiz?
Yes, the quiz is on computers. So on Wednesday, I will not be here. I'm traveling for the next 2 weeks. You have noticed also next week, we don't have any classes. On Wednesday, this will be online. And this is also a question I wanted to ask you. Do you want to do the quiz on Zoom with me being present? Or would you rather get a time slot between 6 and 8, where you do it by yourself, no Zoom? It's open book. I think it's 30 minutes. Yeah. It's open notes. So it's easy. It's drawn in the park. So, no, it's timed. It's timed per canvas. So I would suggest we take it together as a class, because it also will allow that you ask questions. It's a good system that you just chat within. So I usually, this is the first time in person since 2019, right? Back then I did my own quizzes and I designed my own quizzes. I know the students don't like my own quizzes. That's why I went to Canvas, and I let Macmillan do it instead of my own quizzes. So I think the best is we get online, we do this online quiz, and you ask questions. So in person, I would do the same thing. So if we would be here, you would do the quiz still on Canvas, while I'm basically here for your questions. So this being said, well, because it's an online class, I will be there. You chat, and you chat only to me, not to the entire group. You ask me concerning your question, I can check where you are on your quiz. So I can look at that question and I can guide you. I'm not gonna give you the answers, so don't hope for that, but I can help you if there are any ambiguities. So is everybody on board with doing it? In case there's somebody dialing in from abroad, I don't think that's the case for this class. Just get in touch with me and we'll figure something out. I'm accommodating time differences. Any questions for the quiz? After the quiz, since we're doing it all together as a class, after the quiz I will stay on and I'm gonna do a lab day. Otherwise I would just record it. So lab day is essentially walking you through examples that we did throughout the classes, showing you how to do them in Excel or showing you how to do them in R. And that is just good because I want you to really have these codes, and I want you to have the spreadsheets. Because with the spreadsheets, you're gonna have the opportunity to essentially use them down the road when you need it later on. Yes, please.
Is the quiz on multiple choice?
Is it?
Is the quiz on multiple choice?
It's not all multiple choice, but most of it. There's no free text. If there's free text, rest assured that I will go step by step, question by question. Canvas will prompt me to look at these. So there's no need to ask me. I will go through all your quizzes, question by question, and make sure that it's graded correctly. So if there's free text, which is not the case in most, well, there is free text, but you don't have to write actual text, you just have to write words. So you will also need to know the words that are being asked, like a between group or within group comparison, things like that, right? Concept. Yes.
Is the quiz going to be very similar to the practice quiz?
Yes, it's the exact same. So the practice quizzes basically are questions, and the practice quizzes are randomly sampled from a test pool, from a question pool. The quiz is done in the same fashion, and this will cumulatively move up to the midterms, which will incorporate all the questions from all the quizzes. So basically right now we're at chapter 4. With the midterms, we're at chapter 8, I believe. So right now we have 800 questions. By chapter 8, we have 1600 questions. By the end of the semester, we're going to have 16 multiplied by 200. That's like, yeah, a little bit of a larger number. So we're looking at 3,200 questions, from which the questions are sampled for your finals. So it's cumulative. Any other questions? Don't be concerned about the quiz. It's only 50 points. That's not that bad. It's not, we're getting to know each other. You're getting to know my style, where you're getting to know the questions and the quizzes, and just rest comfortably. So it's everything is a cumulative process in this class. I've put a lot of thought work into how this class is structured. It'll be fun. Good. If no more questions, then let's get started with central tendency and variability. Good. As said, So the central tendency is a descriptive statistic that allows to show and describe the center of the data. So it essentially, it shows you values that represent the center, whatever that means. For the mean, for example, it represents the arithmetic average. What that means, we'll discuss in a second. For the median, it determines the middle score, which is the score of all the data points that is right in the middle. And then you have the mode, that essentially is the most common score. You remember how we had the histogram, the distribution of data? The highest bin will be the mode. And we will see that in a second. So central tendency describes the center of your data, which will always kind of shape around the most common entry in your data. If you are estimating this, you essentially, and we have as the example today, we have the Charity Navigator scores. The Charity Navigator is essentially a non-profit endeavor that basically creates the credibility of charity organizations. They all get a score. And so the example basically means to describe central tendency in these scores, in this scores that have been assigned to the respective charities in terms of central tendency. So we have here an average of 87.5. So here the Charity Navigator scores. So please go on Canvas. I have on Canvas, I have these scores essentially mapped out. And I would like for you to essentially follow along with me, because it's kind of nice to look at this in a way together. So if we have these scores here, so if you all download it and you load it as we did in the past, we load it on desktop, in class, and STAT1021G, then we create module 5, which is today's module. And we are loading here the Charity Navigator file from Canvas into this folder. Is that okay? So now we have all these scores here. As we remember, we can always sort our data. So now we sort by the scores. We click My Data Has Headers here, and we're sorting from largest to smallest, which gives us the largest entry. There's only one charity that has 100, a score of 100, which is the highest score. We have 2 with 98.2. We have 2 with 97.9. So we have this whole distribution here. The distribution essentially looks like the one we have here shown in our histogram, right? So this is what the distribution looks like. So if we were to calculate the score, the mean score now, you all must have done, you must have calculated the mean, I guess, in earlier stages of your education, right? So the mean is essentially nothing else but summing up all the entries and dividing it by the number of entries, which is simple. So this is essentially what this means. So we have M standing for mean. Then we have here the sum sign. This is the Greek letter that stands for sum. So whenever you see that, you know that everything that follows this letter means it sums it up. X stands for random variable, which in this case is here our scores. This is, we will talk about this later on, but this stands for an individual entry in a so-called random variable that can take any value. That can take any value and describe something that you're describing with your data. So it's the sum of X divided by capital case N. And N stands in all cases for sample size. Sample size is the number of entries. So this being said, if we are to sum this up now, we easily do this in Excel by the equal sign, sum, bracket, and then we do A2 to A41. That's all that's needed. equal sign, sum, SUM, bracket, A2, which is here score 100, to A41, which is 71.5. That's the lowest one. The sum of this should be 3,613.3. If we want to have our n now, so this is actually the sum of x, right? Sum of x. And now the n is being calculated as, and this is a new function in Excel, which is the so-called count function. Count, and we talked about volcanoes, right? You remember the counts from the volcanoes? So if we do the count, we're counting from A2 to A41. And our count here is 40. With 40 entries, 40 charities were characterized. If we want to calculate now the arithmetic, let's be more precise, arithmetic mean. The arithmetic mean is in distinction of the geometric mean, irrespective, unnecessary now what that is. This is the arithmetic mean where you take the sum and you divide it through the sample size. Good. Arithmetic mean is now the sum divided by the count. 90.33. I took F5, which is here my sum, divided by the n. Equal sign, F5, and the slash pointing to the right, divided by F8, which is the sample size. An alternative, yes. Okay, do you have a sum A2 to A41? Yeah, and now you do count A2 to A41. Yeah, okay, very good. An alternate approach to this is the arithmetic mean can also be calculated with the internal function of R, of Excel, which is the average function. It's like easy, right? It's quite intuitive. It's average A2 to A41. Gives you the exact same thing, and we've confirmed that Excel is doing it correctly. So it's average A2 to A41. Yes. So it's a little, yes.
For the n, you just, is there like a formula or you just count one?
Well, there's a count formula.
So that's.
Oh, what? Here. Count A2 to A41. So your data set, so your data spans from A2 to A41. So A is the column, 41 other rows, or 40 other rows. You can also calculate it, but count is just more elegant. All right, good. This is this. What next? Now we want to have the median. What did we say about the median? So we have now sorted. So the median is the very middle entry, which is easy, right? If it were an uneven number. If it was 39, the number in the middle would be 1920, right? But we have an even number. What we're gonna do now? So if we were to find, so let's number this all through. Let's make it easy. So we have now, so these are now charity ID. Charity ID is now a number that I assign to each charity in our data set, going from 1 to 40, right? So absolutely arbitrary number. So if we were to find now the middle one, we would have easy an easy approach if it were uneven, because then we have 19. Number 19 is our middle number, and then we have more 19s, which 19 and 19 is 38. And if it was 39 in total, then our number 20 would essentially be the middle number. So we have an even number, so we have two numbers in the middle. What we're going to do? Anybody an idea what we could do? Yes. Bingo. Yes, that's what we're doing. So we take the middle two numbers, which in this regard is now 19 and 20, right? We're building the average between those two. That's our median. Or is it 20 and 21? I think it's 20 and 21. 19, yes, 20 and 21. So this is now the average. If we're confirming that now with the median function, it's median A2 to A41. A41 is 20.5. Yeah, but it's B, not A. 90.15. So both ways are possible, right? So you either take the median and you calculate it by hand, or you basically go with the median function. Both give you the same result. Make sense? Good. So with the mode, it's a little bit more complicated because the mode requires you to visually. Now, while you could do it differently, you don't have to do it visually. But I think it's easiest to kind of do it visually. So when you look here at the mode, what seems to be the highest? Well, let's go further. Let's stick with what Macmillan. Everything here was the spreadsheet. Everybody on board with this? Or any questions? No. It's important to, yes.
The A column, you just numbered it?
Yeah, I just numbered from 1 to 40. Yes, I did. Just for the sake of kind of looking at it. We also will need it later for the IQR estimation. So, okay, so it's, yes.
Oh, can you go back to the Excel process?
Sure.
What's the second way of finding the median? Like you could do average and then.
Yes, so this is by hand. So basically I sorted the numbers. I took the middle two numbers and I built the average. That's all I did. So this is the manual way. And then there's a automatized way from Excel. So this is how Excel does it for you. I feel it's very important that these basic calculations, if you have done them, if you have done them once, if you have seen them at least once, it sticks with you. And then down the road, somebody asks you what the median is, you will know this for the rest of your days. It makes sense, trust me. Yes. What? Yes, you need to order it first. Well, yep. So you basically go on scores, you select the column that you're interested in, you go on data, and on data you can go on sort. And if you go on sort, you get this interface. And then you need to select that your data has headers, which it has with this course here. And then you sort it from largest to smallest, or from smallest to largest. That's up to you. And then you just look for the overall count, and then you take the middle ones. And then you build an average of that. Okay? Yes.
Also, I got a different average.
You got a different average. This guy? How did you calculate it? The median. What line? You take 20 and 21, 21 and 22, B21 to B22.
Why those two? Why did you?
Because they're in the middle. So you have 40 entries and you need the middle two numbers. That's 20 and 21. Because it's the middle number that you want. That's the definition of the median. It's a definition. That's why I take the middle one. Yeah. So you find the middle number, and that's how you go for it. Yeah. If it's an uneven number, it's easier because then you have only one number. If you have an even number, you need two numbers to find the middle one. That's it. Yes, you had.
Yeah. So I'm trying to make it into like from the start and everything, and
Yeah.
I tried to make it the category of numbers, but it just came out with
Okay, so that's you need to. Oh, well, you have a filter in here. That's interesting. You're not meant to do a filter. Just do a filter. This one. Now we do two. So now this, you need to grab this one. See this?
Yeah.
That works. That works. Yes, you had a question too? Okay, good. All right, let's carry on. We have no more questions. Good. This is the average. Okay, so this is also important. The mean has different meanings. Okay, so we have. Okay, don't take me too serious today. Okay, so a statistic is a number based on a sample taken from a population, whereas a parameter is a number that is based on an entire population. Makes a difference in terms of your research question, right? If you are studying a large population, you rather use these Greek parameters. So you go for in a population, you go for a mu that stands for your mean, your population mean, or you go for okay, later we're going to talk about a sigma rather for the variability, but here it's a mu. So this is the Greek letter mu. If you have a statistic in a sample, and this distinction will be important for the quizzes. If you have a statistic in a sample, you have either an M or an X bar. And this essentially is an important distinction because we will, with the set statistic, we will compare samples to populations. And then the statistic and this distinction between sample and population will be very important. So please keep this in mind. This will also be part of the quiz. Good. Calculating the median. So we're arranging the scores. We find the middle scores. You either find in an odd number of scores, you find the middle number, or you build an average between the two middle numbers, just like we did. Calculating the mode. Line up the scores in an ascending order. Find the most frequent score. Neither the median nor the mode has an abbreviation, means they're not abbreviated. There's no M bar or whatsoever, or no mu. So find the most frequent score. This is where I said, like, the easiest is to just map it out as an histogram, look at it visually. And so like the highest bar, this is your mode. The mode is not really something that you would commonly describe. So in a scientific publication, you're not saying, okay, the mode in my data was this and this. This is something that you would operationally use in some of your analytic approaches. I have used it for a couple of things, which is irrelevant now for what, but you use it operationally in your analytic approaches, but you wouldn't really describe it. Let's put it that way. Mean and median, this is where the money is. These you really need to know, and you need to know how to interpret them. This is super important. What the mode is really useful for is for a description of your distribution. So in a perfect world, we've talked about the normal distribution. Normal distribution, symmetric, unimodal. Unimodal means there's one most common score. Then we also have, in comparison to that, we have a bimodal distribution, means that there's two modes. Don't have to be the same level, don't have to be high enough, but they kind of will build out two kind of peaks in your distribution. Then we have multimodal, and this is the nightmare of every statistician, because then you need to stratify, but that's a whole different conversation, please. Good, so basically the mode determines how many peaks you have in your data. So this is a classical bimodal age. And this is why it's so absolutely crucial to depict your data visually, because you need to understand that, right? So the name violet has been a very popular name in the earliest 20th century has decreased in popularity over the 40s, 50s, 60s, 70s, 80s, 90s, and has then had a renaissance in the early 2000s. So now when you look at the median number of all these occurrences, it's somewhere here in 60, I would say like 68. I was like Woodstock. So the median aged violet at this point in time is 47 years old. So now when you think about the median and when you think about two modes, you see that the median alone is not telling you anything. You have just no idea what's really going on with your data. So this is why it's important to understand the modes, understand how it shapes, understand how it looks like. And this is a typical bimodal distribution. You see this also in survival analysis, you see this quite a bit. So you have like, if somebody survives a certain period of time, then you basically have a decrease in mortality risk. And then at one point you wait a couple of years, then this risk increases again because the age kicks in as a factor. But this is for a different conversation, please. Yeah, so, but this is important. It's like always map out your data, understand your data, feel your data. Okay, charity navigator data. Now we have an inclusion of also the lowest point. So this data that you have seen did not include the lowest entry. So given that the charity navigator data likely kind of characterizes the credibility of this nonprofit organization at hand, this is the nonprofit organization you should not donate your money to. So essentially, you are looking at a wide distribution of charity navigator scores. And it's important to keep that in mind, because if you start calculating central tendency within a data set that essentially has many outliers, you will arithmetically, remember how we calculated the mean? We're building the sum and we're dividing through the number of entries. So this mean will be pulled towards the direction of your outliers, which is a problem. If we are, so this very same distribution here, we're excluding the outlier in at 4550, we're basically looking at an entirely different mean. So this is how sensitive that is arithmetically. So, and this is also where these different measures of central tendency are important to always compute. And you need to compute them and you need to compare them. In a perfect world setting, in a perfect normal distribution, mean and median are identical. They are not always, unfortunately, because the median is less resistant against outliers, meaning the mean will very sensitively move towards the outlier. The median will stay considerably resistant, whereas the mode is rock stable, doesn't move at all, because it's the most frequent number, right? That's all it is. If you put a couple of outliers there, the most frequent number is still the most frequent number. So this is not going to change. So it's important to understand that, because when you have a skewed distribution, and again, this is where you need to map out your data. If you have a skewed distribution, you would rather use the median than the mean for characterizing your central tendency. This also goes in that direction if you have normally distributed data, quote unquote, parametric data. And this is mainly what we're being discussing in this class. Non-parametric analysis we will not be discussing. You would always use for parametric data, always the mean. For non-parametric data, you use the median. The mode is used if you have one particular score that dominates the distribution and you're kind of interested in that for operational reason in your analysis, or you have a distribution that is bimodal or multimodal and you want to describe that. Or thirdly, when you have nominal data. Nominal data, as we know, is like where we have groupings that are determined by whatever rankings or by, I don't know, whatever group you could have that essentially contains count rather than a numerical value. Okay, any questions of central tendency? Because now we're coming to the second part of it. Yes. Well, so the question is, how can you recognize whether it's bimodal or multimodal? So this is what you would do with a histogram. So you remember how we looked at histograms and we saw like the shape of histograms of whether it resembled a normal distribution, where a normal distribution is unimodal. So when you see something that has more than one mode, like this here, where we have like this increase and this increase, you would judge this, or you would characterize this as bimodal distribution. If you have more than one, you have a multimodal, a trimodal, or quadrimodal, or quintimodal distribution. So you can characterize it based on the modes. Well, there's one mode and there's one mode. They're not equally sized. But you go kind of by the eye estimation. Yeah? Okay. Carry on. Okay. When you're characterizing the central tendency, you also need to characterize the variability. So think of the normal distribution again. We have the bell curve, we have this one mode, and we have a symmetric. How did I manage that? Okay. So we have variability. So we have the unimodal distribution, symmetrical distribution on the sides of this center. And now essentially we also want to characterize, so this bell-shaped curve, what's the diameter of the bell? So how far out is this data distributing around the center? So the ways how you can do that to describe this spread is by either characterizing it as a range, which is essentially the lowest to the highest score, or as the variance, which is basically the deviation from the mean squared divided by the number of entries. So it kind of characterizes the area of that spread. The standard deviation is the variation from that sample mean divided by the number of entries squared and square rooted. But we will do this calculation in a second. Okay, so calculating the range is the determination of the highest score and the lowest score, and then it's the subtraction of the lowest score from the highest score. So this is easy, right? Can easily be done. And we're gonna do this right now in Excel. So we're going back in the Excel. We do now the range. And we can have max, min, and now we do range. So the max is characterized by MAX, equal sign MAX, B2. So now it's B2, it's not A2 anymore. B2 to B41. So our max is 100, right? Which we know because we're seeing B2 right in front of us. So now the min is equal sign MIN, B2 to B41. So 71.5. So now the range is 100 minus 71.5. So the range is 28.5. Easy, right? Not really complicated. Any question on that? I think that's as easy can be. 28.5. We have max and min. That's the B2 to B41, max and min. And then the difference between max and min. Yeah? All right. Interquartile range. So now, we need for interquartile range, we need firstly, we need to understand what the percentiles are. The percentiles are essentially, so you have 100%, right? So you take your entire data and you basically, you take every entry that you have and you can stratify that into percentiles. So you can say your 5th percentile is that where 5% of your data is below that value. If you take 20th percentile, it's 20% of your data is below that value. So essentially what you want to do is you characterize your entire data set with this percentiles. So if you do a median, it's the middle number, you have 50% of your data below the median. So if you have the first quartile is the median of the first 50%. So you make the median of your first 50%. And equally, you're taking the third quartile for the 75th percentile of your data set. And the interquartile range is the distance from your Q1. So this is your first quartile, where you have 25th percentile to 75th percentile. So this is your middle 50%. It's important when you see a box plot. Does that make sense? Because it's easily shown. So we have now 20 and 21, that was our median, right? So now we have, we want to do this as a median. So this will essentially, we're doing now median of these 20. So that's 95.3, that's our Q1. And now we do a median of these. That's not 21 to 40, which is 87.8. So this is our Q3. And if we want to calculate now our IQR, the only thing we need to do is we're subtracting Q3 minus Q1, or vice versa. Of course, because it's so that it's ascending. So this is 6.5. That's the interquartile range. Yes? By taking the first 10 entries or 20 entries and building the median. So you take the median of the first 50%, you take the median of the second 50%, gives you those middle points for your data. And then you just need to define 25th and 75th percentile, and the distance between those is IQR. And these are the exercises where I think it's very, very helpful that you know how to run those in Excel, because you may get this on your quiz. And if you need to map out this data then, and you need to do this by hand, that's, well, less fun. Let's put it that way. Make sense? All right, so this is the IQR. Yes. Yeah. Okay, so we have median B2 to B21. Yeah. So once you have, okay, so you have the median from B22 to B41. And then you can calculate the IQR by subtracting, oh, this is actually then the Q3 story. This is Q3, this is Q1, because I sorted ascending. No, descending, not ascending. Okay, so the difference between those two, in my case, D10 minus D30 is the IQR. Yeah? So exactly. So you get, this is not a median at this point anymore, it becomes a Q3. And then you do this Q1. So you do Q3 minus Q1. And that gets you the IQR. Correct. Per definition, that's the case, yes. And Q2 is the median. The median per se would formally be called Q2. You may find that in some context. All right? Make sense?
What is this data telling us?
This is the Charity Navigator score, which is, I think, as per the Macmillan description, is a non-profit organization that scores the credibility of charity organizations in terms of the. Well, so it helps to characterize the variability in your data. So you basically, if you think of a distribution, you want to characterize what the central tendency is, what is the center, and how does this data spread around the center. So the range gives you all the outliers. The interquartile range gives you gives you a characterization of the most part of the data, because this middle 50%, that's actually the quote unquote most common data points. So it kind of gives you an idea how wide is your data spreading. And the IQR specifically is something that is mainly used with skewed data, where this is more important. For normally distributed data, which is very symmetric, you would rather use a standard deviation, which we're going to do in a second.
What is the formula to the interquartile range?
Yes, so it's the Q3 minus the Q1. So this is here. So we're subtracting Q1 from Q3. So it is here on slide 17. Then calculation of the variance. Any more questions to the IQR? Yes. Q1 minus Q3 minus Q1.
No, what did we get to Q1 first?
So we're building a median of the first of the lower 50%.
So you could just do average.
No, you do median. So you take the lower 50%, which is from the median downwards, which is B22 to B41. You do the median of those, and then you do Q3 by doing median of B2 to B21. Yeah? All right. Yes. The which?
Do you include the median score in Q1 and Q3, or which one do you include?
Well, we have even numbers, right? Then this is now the problem. But you're hitting a very good point there, because there's actually a discrepancy between statisticians whether you would include with uneven numbers. This is a problem, right? With uneven numbers, you essentially have the issue that you have one number in between. What are you going to do with this number? If you do the lower 50% or the higher 50%, are you going to include the number? Are you included in both calculations? Are you included in only one, or are you not including it at all? So it's not really determined how you do it. Personally, what I would do, I would include it in both.
In which?
In both. So I would take the lower 50 and the higher 50. But it is a discrepancy. It's actually funny when you look it up in Google, you actually find statistician bickering around which is the right approach. It's kind of entertaining. But yeah, I would include it in both. So if you're asked to calculate it by hand, which is likely not going to happen often in your life, I would include them in both. I think it's the right approach. All right. Any other questions? But that was a good question. I like that. Good. All right. Variance. So now we're coming in the realm of normally distributed data. And now it's getting a little trickier, because now we're calculating now for 40 entries. We're calculating now 40 differences. These differences are essentially the differences. You're gonna tell me that I'm in the way. Okay, so we have 40 entries, and we're subtracting these entries from the mean. So this gives us 40 differences. So these differences have now an issue. So because these differences essentially, since the mean is the arithmetic sum divided by the number of entries, what will happen if I sum? So again, here we have this weird Greek symbol again. So essentially, we're summing them all up. If you're summing them all up and you have negative differences and positive difference, what's going to happen? They're getting zero again. Exactly, because that's how you came there in the first hand. You get the mean by summing them all up and dividing by the number of entries. So if you're now starting to subtract something that built that mean and you're subtracting it again, you end up with zero. So for that very reason, you're squaring it. And you're taking the sign out of the equation. And by that, you start building up a positive number, a larger positive number. And this positive number, this will haunt you this semester, because this is called, because you're squaring it, you're building squared deviations, and this is called the sum of squares. And this sum of squares is quite central to various arithmetic statistical exercises, most foremost with the analysis of variance de novo, and then later with regression analysis, which we will touch both on later on. And you would not like me. Okay, so but we have the sum of squares, and once we divide the sum of squares by the number of entries, we're getting to what is called the variance. And the variance is basically the ST squared. It's the ST squared because the standard deviation is the same thing, but you basically square root it, and you're taking the square out of the equation. So this is how you characterize variability in a normal distribution. Okay, but back to the variance. Okay, what you do, you're doing this. You're going back to, let's go back to the Charity Navigator. We have now a mean, which we have calculated here, right? So now let's select column C. Let's insert 2 empty columns. Let's take the highlight out. And then we're calculating. We're calculating x minus x bar. Yeah, x bar. Okay, let's not call it x bar. This is too confusing. So x bar. I'm saying x bar because later on in sample statistics, you will basically x bar will indicate that this is a sample mean. But forget about it. We call it m. X minus m is x minus the mean. So we have a mean that has been calculated already. So the x is here 100, for example. If we're doing 100 minus the arithmetic mean, which is 90.33.25, 90.3325, we are now locking the mean in. We have done the locking in, right? This was this confusing dollar sign I was keep on talking about. And you're locking it in means that whatever you're going to do now with this formula, if you're dragging it down, it will take the respective score in each row, but the mean will always be the same. So this cell you're subtracting from that score will always be the same. So if you're going to, yeah? That is B2 minus $I, $11. But it depends what your cell is, right? So with the dollar sign, you're locking it in, and then it will remain, it will refer to the same.
How do you know when you have to put the dollar sign or when you don't?
Well, it's a use case on a use case basis, right? So if you want to subtract something that will not change no matter what you do, because what I want to do now, essentially, I want to make my life very easy and not type this formula over and over and over. I want to just drag and pull it down. And this will always refer to the same mean. That's when you will lock it in. Otherwise you don't. Because here the B7, this was up here, it was B2. Here it changed to B7. So basically by pulling it down, you have it count forward, and it goes basically with the row you're pulling it down. So this will change with the pulling, whereas the mean does not change. It will always refer to the same cell. So it really depends on your use case, and it depends on what you want to do. So now, basically, I pulled this down now to 41, and here it becomes negative, right? And now let's put this to the test, what we said before. If we're summing this up now, which is now sum B2 to B41, we're getting a number which we know already, right? So if we are C. Okay. Yeah. So this is virtually 0, as you can see. And this is proof that the squaring does make sense. So if we do x minus m squared, and this is designed for squaring something. If you want to square something, you have to use this little head. So you essentially are squaring now your deviation. You're squaring that up all the way down. And now you see no more negative numbers. And you're summing now D2 to D41. And this here is your first sum of squares. Commonly abbreviated as SS, which you will see quite a bit there. Okay. We're making this yellow now. Okay. So this is the sum of squares. And we said from the sum of squares coming to the variance. Yeah, I see the hands. Just give me a second. I'm going to see in a second. Variance is now this divided through our n, which we have calculated here already. And this is now 34. So this is our variance. Yes. You're not adding another column. Okay. So you just click on the column, and you make a right click on top on the number, and you can insert, and then it will insert a blank column. Yeah, you're welcome. Yes.
Where did you put in under x minus m squared? What's the point of that?
Which one? This one? Up. Okay. This one? This is the square. Yeah. So we're taking the deviation x minus m and we're squaring it up. Yes. Okay. The x minus m. Did you put the dollar sign? Yeah. You have the dollar sign. Okay. Any questions? No? Yes.
For the sum, you just add everything in the
Yes. So the sum of squares is the sum of all squared deviations. Yeah. And dividing this sum of squares, by the sample size gets you the variance. And now the step to the standard deviation is obviously the most easiest one, because the only thing you need to do now is to take the square root of the variance. And this is your standard deviation. As easy as could be. Yes. Square root of variance. You're welcome. Yes. Okay, x minus m is your entry, the score, B2, minus the mean. But you need to lock the mean in with the dollar sign. And then you're pulling it all the way down. And the mean will remain the same, the individual entry will change. It should not give you the same value. Okay, so try B2. Okay, go on C2 and write B2 minus dollar column of where the arithmetic mean is, dollar row where the arithmetic mean is. I will post a spreadsheet so you can look at the spreadsheet. Okay, let's do that. Just for the sake of getting further, I would just, well, actually at the end of it. Okay, the last thing I just wanted to show you here when it comes to, I'll show you in a second on how to calculate. So the last thing is, so you remember how we have population mean as the mu, as discrete mu, and we have population or sample mean as capital M, capital case M. We have the same situation here with the standard deviation. We're either doing ST square for variance, S square for variance, or MS as the variance. Or we're doing ST or S for standard deviation in a statistic, which is for the sample only. For a population, we're doing sigma. This is basically a little O with a little thingy on top. So it's sigma. Or we do sigma square for variance. This is just important that you recognize it whenever you see it in the quiz. It's important as a distinction because later on there will be some calculations where this becomes relevant. Okay, that's the end for today. I think we can conclude a little earlier today. I will post an R code as well, and I will post this spreadsheet that you can practice this down a bit. Whoever has a question on the Excel spreadsheet, I'd be happy to answer it now. But I think we're good for today. Make sure to study for this quiz, please. Yeah? And we see at 6:20 on Wednesday, online only. I will post a link. I will be online at 6:20. I will be online at 6. Let's do it that way. In case there are any questions, any burning questions, put it on discussion board, shoot me an email. Make sure that you make use of the discussion board. Everybody should monitor the discussion board. Let's make this kind of an interactive story. We've gotten a smaller class, so let's make this worthwhile, and let's have an interactive kind of communication flow. I think it makes sense. All right, good. Have a nice evening and study hard. And let's talk soon. No, we can turn it off now.